Action!
Hi, everyone. I'm Beth Johnson, and with me, as always, is scientist Frank Marchese, and this is the Grudge Report. We're continuing our special 10-part series on the best of Stargate SG-1. We're covering one episode per season as chosen by Stargate fans on gateworld.net, and thank you, Darren, for all of your assistance behind the scenes. This week's show is on Season 4, Episode 6, the Time Loop episode, Window of Opportunity, best episode ever. Hi, Frank. How are you doing?
I'm good. How are you, Beth?
Good. Did you enjoy?
Yeah, it's a very fun episode. It's definitely the most humorous one, I would say.
Yeah. No, there's definitely a lot of humor in it, and it still has, it still has a science premise going on in the background, but it was very funny, and it kind of touched on things that I thought were fun and interesting, and took it to a different level. I mean, time loops are a trope in science fiction. We've seen them in everything, and to see this one, I remember originally watching it when it first aired and thinking, oh no, a time loop episode, this is going to be so bad. And then it was just absolutely not bad. It was the best. Even this time, watching it through again for like the third or fourth time, I still cheered when I always cheer, and I laughed when I always laugh, and it's just still really good. So I'm glad we're getting to do this one. I look forward to this one. So, science. Let's talk the science. All right, we're on a planet called P4X639. They've gone here basically to study this magnetic field geostorm going on. The sun is giving off coronal mass ejections, which they call coronal mass emissions, but the terminology has changed in the interim. These are very large solar flares that can be very damaging to our communications and GPS systems here. So actually a big issue. And I think we've talked about it before, and talked about how our FDL teams have worked on trying to predict when these will happen and how to give advance notice and all that kind of thing. So that's actually a big deal scientifically. So that's what they're there to measure. And I have to remind myself that this is, like 20 years ago, and we didn't understand coronal mass ejections as much as we do now. Like, we've done a lot of stuff on them. We have like solar orbiters that are gathering all of this data, and so like the science has changed a little bit in the interim. So nowadays she wouldn't have to be out there like measuring it to figure out if it was dangerous. She'd be out there going, yeah, that's going to be dangerous. Let's like set up instruments and leave. So that was a little different. I thought that was kind of telling. So what can you tell us about this geomagnetic field storm that's going on? What did you wander off and learn something like you always do?
Yeah, I did learn stuff. In fact, most of the time in science, we use, when it's not our field, we use a term like geomagnetic storm without really understanding what geomagnetic storms are truly about. So I kind of make some research about it. Most of us, that around Earth we have this magnetic field, right? Very useful magnetic field produced by the motion of magma in the interior of our planet. And this magnetic field is kind of a dipole shape, so it's protecting us from radiation coming and from particles coming from the sun, for instance, because the sun is not a perfect star. We used to think that in the past. Probably that the Jesuit thought that the sun was the perfect, didn't have any imperfection. But now we know, when you look at the sun with a telescope, you see the dark spots. When you look at the sun with a H-alpha band, at specific wavelength, you see some flares coming out. Mm-hmm. So the sun is not burning regularly. It basically has some bursts and activity as a cycle of multiple years, 11 years. And that's a problem. That's a problem, right? Because this sun is, when it's very active, is basically sending us particles, and that's from what we call a geomagnetic storm. So those geomagnetic storms has those kind of disturbance into the magnetic field. So it's when you have a magnetic field and you send particles which are charged, basically the magnetic field change shape because it absorbs some of the particle. I mean, there is a very complicated physics here called plasma physics that I studied when I was doing my master, and I happily forgot about it. I don't know if it's the case for you, Bess, but it's one of the fields that I loved it, but frankly, I was very happy to forget about it.
I think all of us in science have at least had that one thing. Unfortunately for me, it's E&M. So when we get into a lot of the magnetics of stuff, I get very like, nope, no. I mean, I understand with so I know like with star spots and particularly with solar flares and then these coronal mass ejections, what happens is the magnetic field lines in the sun, of course, we always think about like they're these perfect dipoles. They come out one side, they go around, and they go back in. But it's not actually true. And the way, because the sun, like the Earth, is spinning at different velocities at different latitudes. Sorry, trying to find words today. So what happens is the magnetic fields aren't spinning as fast in some places as they are in others, and they tend to get tangled up. And then when they get tangled, they make these solar prominences, and then those solar prominences, the field lines snap, and then you get these solar flares, or you get bigger ones where you get these coronal mass ejections. So it's not this perfect ball up there in the sky. Like there's always stuff going on, except as you pointed out, like there's that 11-year cycle that we have to go through where it's like, okay, it's really, really active. It's really not active. And I know from a few months ago, people were still saying that they were taking images of the sun and it was still very, very quiet. Like there was like no sunspots, which is rare.
And a month ago, the first one appeared, and since then there is a lot of them. So
right, and it's just kicked up, like it's just ramping up now. So this particular star, two things I noticed. One is that it's obviously much closer to the planet than our own sun is, because when Jack pulls out his protect your eyes from staring at the ball of fire in the sky, he's not looking at like a little tiny dot and seeing like just little bits of stuff. He's looking at, the full, like he can see it clearly in detail and see these solar flares and coronal mass ejections coming off of it and how active it is. So it's definitely closer, and it's definitely very active. And so that was very striking to me that, we're on this planet, and it's, how is this planet habitable? Like, right? That's an issue on this. Okay.
What you're seeing is not a star, is not a G-type star. It's a G-type star into the red giant phase. Oh. That's why it looks so big in the sky. So that's why when you look at it. So just to summarize, and our audience probably know that the sun, when it's going to get older in 4 billion years, will basically start changing its fusion reaction. So we'll expand inside, become a red giant. Okay, and those red giants are bigger, so big that they can reach the orbit of Earth. They will swallow one day Earth. So what we're saying here is probably a star, a G-type star or K-type star, which are entering in the red giant phase. So still very active. So it's big in the sky. And the reason you mentioned how come this planet was or is habitable, and because it was habitable when the G-type star was a normal state, and it probably gradually warm up, and that's why it's kind of a desertic around it, as the planet grew in size and the heat increased on the surface of the planet. So that's my theory. I'm sure someone's going to say that's not real because there will be some details I missed. But I think that's the most interesting theory to explain why the planet was habitable, why the ancients used to live there, why did they build this artifact, and now the planet doesn't look habitable at all.
So what you're saying is this is sort of Earth in like 4 billion years. Yeah. Okay.
That's what will happen. They will come and they will basically see our technology that we had developed by then, extremely advanced, and will be the same. And it will be Latin too.
One of the things about this particular technology is that, of course, this causes a time loop, and we go through many, many iterations of Jack and Teal'c's day. And I think the main reason that this episode works as well as it does is because the scientists are not the ones stuck in the time loop. So, you get the humor of the two non-scientists trying to convince everybody that this is happening, and you realize that they have to do this every single loop. They have to start with, yes, here's the thing, blah, 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 loop. Okay, can we now move on? And now they at one point they get informed by Daniel, you guys are going to have to learn this stuff and you're going to have to memorize it. And then it just starts to get into like what the human side of being stuck in a time loop is. Like, it's not the science side of being stuck in a time loop. Like, we're not just watching Daniel and Samantha try and solve everything. We are watching Jack and Teal deal with a repetitive day that starts with the same food and the same smack in the face. So it's not exactly like the best timeline to be stuck in. Yeah. And they have to try and like figure out how to solve this problem in a way that means, these are two people who are not equipped to do this. And so it's really like, I think that's the main reason why this particular time loop episode works as well as it does, is we do get to see that human side of it. And Daniel offering up that sort of philosophical challenge of, there's really no consequences. You can do whatever you want.
Yeah, let's talk about that after. Before we talk about this, I want to... something very interesting is that despite the fact those two non-scientists are the ones stuck in the time loop and that remember everything, ultimately it's science that will save the day, right? So they have to learn the science. And you can see that they do. Like after a while, after I don't know how many repetitions, probably hundreds of them, they stand up and they start writing on the board in Latin, the translation, etc., because they learned it. And that's a very positive message in this episode, is that anybody can do science. And that's something I keep saying, and I'm going to say it again. Science is not reserved to an elitist part of the population living in an ivory tower. Science is for everybody. And if you equip with it, if you have the time to learn, you will learn the scientific method, you will learn scientific facts and know how to use them. And that's exactly what happened in this episode.
It wasn't Jack's wheelhouse. It has never been Jack's wheelhouse. It's established throughout, from the movies through, that he does not like the scientific speak. He just wants the bare basics. Just tell me what it means for me. And then in this episode, like even Samantha's kind of like, have you ever heard him use this terminology? And he used it correctly. Yeah. So, he's actually processing it and learning it and understanding it so that when they get to the planet, he explains things and Samantha just sort of looks at him like, huh, that's like, or something, and he's embarrassed that he's picked it up, but he's actually brought that in and internalized it, which I think is amazing. And again, a good lesson for anybody. You can learn science. It's not all calculus and pain, okay? It's really not.
It's also very fun, and you learn stuff by having fun as well. And they do that in the show as well. I mean, those moments where they start playing golf with the gates and doing things that they really wanted to do in this time loop. I mean, it's without having any consequences. It's a fun thing.
Yeah.
I don't know what
it is a fun thing.
What would you do if you were stuck in a time loop like that?
If I were stuck in a time loop, we can
talk about on YouTube, okay?
yeah, something we can talk about on YouTube. What would I do if I were stuck in a time loop? See, I think this is a very valid question, and I think our audience would have different answers too. So, I would catch up on all my reading. I know that's one thing I would do. I would just no, go away, I'm reading. I would probably work on my foreign languages that I never have time to work on, because I think you can pretty much master a language in that time. If the movie Groundhog Day has not taught us anything, it has taught us that we can, master an instrument or a language. I don't know. I don't know.
Yeah.
Because you can't get very far. You can't do a lot. I mean, this in this case, it's a 10-hour time loop, right? Like, it's not even a 24-hour time loop like Groundhog Day was, right? This is 10 hours. That's all you have. So what can you get done in 10 hours every day? I mean, nothing you do physically is going to make a difference, right? Because you're just going to go back.
Yeah, exactly. So it needs to be something.
It's only your mind. It's only things in your mind and learning that you can do. So I would definitely not work out all the time.
I will learn piano or something like that. I will take the time to finally learn how to play piano.
I think if I could get my hands on one, I think but see, that's the problem. You can't get your hand on anything.
Yeah, but that's why I have one at home. I have one at home that I purchased a long time ago, and it's still there, and I still have the desire to learn it, but I never really did it. So if I'm stuck in a time loop in my home right now, this is what I will do. Definitely.
On that kind of note, does it feel like you've been stuck a little bit in a time loop during the pandemic?
That's exactly where I wanted to go. You're reading my mind. Yeah. So for the people in the future that are watching us in 2025 on YouTube or 2060, we are recording this in 2021, and we are still in the end, hopefully, of the pandemic. But we had the year 2020 was truly for me, a Groundhog Day, definitely.
Very much a Groundhog Day. We started using the term Blur's Day for what day of the week it was. It's like, unless I had something regularly on my schedule, I was completely lost as to what day it was. Oh, okay, I don't have to work today, it must be Saturday. Because that's all I had going for me, was like, what, I think my son being in class on certain days of the week and at certain times was really helpful, because it was a schedule we had to follow. So yeah. I can't imagine, like, I mean, I guess I can imagine being stuck in sort of a time loop scenario.
So that makes me think about, we talk a lot about when we are going to travel through the solar system, and it will take years, maybe months first to go to Mars, and then years to go to Jupiter, if we want to send human in spaceship, right?
Right.
Well, that's something we're gonna have to think about. I'm not a psychologist again, but I'm pretty sure this pandemic will probably teach us how to handle this kind of monotone existence where you are stuck in one place and you have to basically work, but you need to keep the people happy, because I'm sorry, but the last thing you want is to have some astronauts or cosmonauts or spationauts, whatever you want to call them, from the nation you are from, landing on Mars completely depressed. You want them to be like happy,
or murderous
about the project.
Yeah, or murderous with each other. I mean, those of us who have been in pandemic lockdown with our respective spouses and children or other family or other roommates, it is a challenge to be with the same people. I was thinking about that actually watching the episode too, because these guys basically live and work under the mountain. We don't see them go in and out a lot. Mm-hmm. Like, I know they have houses off the base and that they do go to them, but they're rarely off, right? Like, they have their quarters down there, and there's no windows, and it's all underground. And all I could think was that would just start to get to me after a while.
Yeah.
And so, and that they must be living there because they're eating breakfast.
Let's not underestimate the resilience of human beings. I think we are capable of doing surviving in bad environment. I mean, the pandemic or being stuck in a place is bad, but we survive. What my concern is that we need to make sure that when we arrive on these planets, we still have the motivation and we still have clear the mission still in mind. And I don't know for you, but for me, after like a year of pandemic, some of the stuff that I thought was extremely important to me became very details, and I basically dropped them.
And there were a lot of things where,
but this scientific project as well. So it's
we started. I feel like we all started the pandemic with, okay, I'm stuck in my house. I'm going to do all those things that I've put off doing. I'm home. I've got time, and then I don't feel like many of us really accomplished that list that we started off the pandemic with. That a lot of it became, this isn't as important as I thought it was.
Mm-hmm.
I'm just going to put it aside. Like, the places in my house I thought I was going to finish are not finished. But other areas like this desk, became very important to me. Like, I need this workspace. And I was working from home before the pandemic, but now everybody is. And so, I had my kid, he's across the room from me, and I have my husband was working from home less than normal, to be honest, because he realized that in order for us to survive, he needed to go into the office to do stuff. And since he was on the list of people that was allowed to be in the office, he's IT. So, you have to actually go physically do things sometimes. And it became very important, like how we divided up the space for working constantly with each other. And so what was important at the beginning of the pandemic stopped being so important the further we got into it. It was like, no, let's make it so that we like love each other at the end of this. So speaking of pandemics, and back to the show before we get too out in the weeds here, the ancients, the whole reason this thing starts, like the whole reason this machine exists, is because the ancients, which of course, if you've watched all of Stargate, you know far more about than we did at this moment in the series. But they made the Stargates, they put them out there, and they built this machine, and they did it so that they could go back in time and not be wiped out by a pandemic.
Yeah.
And they had the same problem. It failed. They got stuck in this 10-hour time loop. And, you know, so it even the greatest of minds can be wiped out by an illness.
It's interesting. When I heard that, it's the first thing I thought about. I said, wow, yeah, it's possible to have a very advanced civilization wiped out by a pandemic. And I do probably remember last episode I mentioned the 4 ways we think that the advanced civilization can disappear. There is nuclear or nuclear destructions or any other weapon. There is a technological disaster like grey goo that we mentioned in the previous episode, pollution of the star, the planet, or supernovae. And there is the biological or chemical agent that design or end up killing the species,
right.
And that's what we had in the case of the ancient. We don't know much about it, but apparently it happened. And that's a problem for any civilization. Any advanced civilization will always face pandemics. That's something that has happened in our history regularly. In the Middle Age, we have memories of that. We have texts showing what happened there, like wiped out one
third of the population of Europe was lost.
Something like that in Europe. We have probably pandemic that happened in other parts of the world that we don't know about because there was no writing at the time. But we also pandemic like the Spanish flu in 17, 18, and now we have this one. So the issue here is our species need to cohabit with the rest of the ecosystem, the biosphere. And this biosphere is not always friendly. We are more and more numerous. This biosphere mutate, viruses or microbes mutate. And one day it can happen that's exactly what happened apparently for the COVID-19, is that one day one of the virus mutate enough to be able to be transmitted to human, and then start the pandemic itself by having this human transmitting the sickness to others, etc., etc.
And even now we're seeing several variants of it out there as it continues to mutate, and so it's not a. This is why people can get a cold over and over and over again, because colds are caused by viruses, and viruses don't always replicate exactly the same way. They mutate very easily because they do reproduce so much so quickly.
Yeah. So our antibodies are great, but they somehow need to be trained to be able to destroy or to isolate, to identify this virus or this bacteria. And if the virus is extremely different because it's coming from another species, then we will not have the antibodies. And that's the reason vaccinations is important, because that's the way you basically train a body to become to learn about to develop the antibody necessary to destroy a virus when there is first being attacked. And
so it's interesting that the ancients didn't somehow find that, right? I mean, that's, here we are, we're in the middle of this pandemic, and we've got 4 different vaccines running, and it's a whole new style of vaccine, and I've had mine, and that's great. And yet the ancients who built the Stargates, who obviously knew how to travel from world to world to put them there, could not, on this particular planet, conquer a pandemic. which tells you that sometimes biology will win out faster than intellect.
I think People underestimate a lot the biology and the complexity of biology. I mean, we do have viruses that we still don't know how to cure because they mutate too quickly, like HIV is one of them, for instance, despite the fact that HIV appeared on this planet, started infecting human beings in the 80s, we still don't have a vaccine. So because the virus is mutating too quickly for us to develop this vaccine, that's and that could be a problem. If imagine that a virus like this is deadly, more deadly than COVID-19 or more deadly than any other, and transmitted easily airborne, for instance, that would be a disaster. So that's why we need to continue to invest in this technology and continue to invest into having plans and getting ready, because it can happen anytime. And
so what we've learned,
but it's important to be ready for that, because that's the way. If we invest money to protect our planet against asteroid impact, we should invest some money as well to get ready to study viruses around us, to make sure that we know how to counterpart them. I mean, the coronavirus is a virus that was known before. It's not. It didn't come out of the blue.
No, it's a particular type of virus we've had around.
And some researchers spend hours and hours in the caves of where there is bats to pick up those viruses. And people always ask, what is this useful for? Well, now we know why. So now when you hear about this research, I know it's not fancy to pick up from faces of bat viruses, but it's really that's what saved us in this case, probably.
So what we've learned from the best episode of Stargate 1, which is also probably the funniest, is that on a very deep level, you have to manage the electric storms that you're going to deal with from your sun, no matter if it's in the middle of its going into red giant phase or not. Those storms can take out our communication systems. So invest in figuring that out, because that's important. Invest in virological research, because these things, as we've discovered in the last 18 months or so, can really wipe out a lot of people pretty quickly. And if a technological civilization at the height of its technology can be wiped out by a pandemic, we need to work better about it. And 3, anybody can do science. So there's all kinds of ways to do science. You can participate in all sorts of citizen science projects out there. You can use your telescope to look for things. You can use your eyes to watch for variable stars. You can go online to any number of citizen science projects and hop in and identify galaxies or map migrations of animals. I mean, there's all kinds of ways that you can participate. Yeah. And
the universe is a repository for that. It's the best website to find some of them.
Yeah, Zooniverse has tons, and it's not just their Galaxy Zoo projects, which is where I got started on doing citizen science. It's a whole bunch of other projects. So keep your eyes open. There's so many. And if you want to still dedicate your CPU time, because I know some of you are missing UC Berkeley's Study at Home project, there are all kinds of others. Einstein at Home is still running stuff. There are some that are actually working on the coronavirus. So if you take a look around, you can find all kinds of them. So
we
science,
have one,
science is for everyone.
My colleagues at the Upsala University have one of the projects at the server you mentioned to calculate the shape of asteroids. For instance.
So there you go.
Do that. So see,
so whatever your scientific interest, whatever your interest, you can find some things to do. I know there's some that are even doing like transcripts of English documents that are written in that old English that are hard to read, and so they're trying to they're getting people to help transcribe them into more modern day English. So whatever your field of interest is, you can find some citizen science to do.
Your imagination is the limit.
Yep.
Remember that.
Any last thoughts on this episode, Frank? Did we cover everything you wanted to cover?
I think we covered everything. It was an intense conversation, by the way. I did not expect something like that. But thank you.
All right. Well, thank you everybody for watching. This has been the Grudge Report, and Frank and Margaret will be back next time with the next episode of The Expanse. And I am in discussions with Darren over at gateworld.net to bring us possibly some Stargate Atlantis and Stargate SGU reviews. So we may have to really catch up on some stuff. because I know Frank has watched all of SG-1, so we're going to figure out what we do after this, because we've only got 6 more left, which doesn't seem like a lot, but it'll go quickly. All right, everybody, thanks for watching. Make sure you leave comments at the bottom, ring the bell, subscribe, like, and we are a nonprofit. So if you are interested in supporting our science and as well as our outreach projects like this, you can join us over at SETI.org. Have a great day, everybody.